So we're going to look at two styles of equations today. All right. We'll first look at exponential equations, which we've already discussed how to solve simple exponential equations. Those were like the bonus questions on the quiz. All right. So yeah, spoiler alert to those of you that haven't taken the quiz yet. There are bonus questions and they're simple exponential equations. Okay. But that's where you try and get the common base, right? And then once you have the same base on each side, you then drop the bases and just set the exponents equal to each other and solve from there, right? We talked about those, several days ago. But today we're going to look at how to solve exponential equations when you can't get a common base, like what we saw in the warm-up today. Then we'll also take a look at how to solve equations with logarithms in them, okay? So let's take a look here at what we're going to do. So, oh, that's the wrong thing. Sorry, I'm trying to make sure I get the. Oh boy, now I'm confused. Oh, wait, this is what I want. Yes, this is what I want. Okay, sorry. So, like I said, we'll start with exponential equations. When you can't find a common base. Now what I'm going to show you here will also work for situations where you can find a common base. Okay? So this will work to solve any exponential equation, potentially. All right? So we'll start with the very basic one. Whoop. Okay. 4 to the x equals 11. All right. So we run into a similar problem like what we did for the warm-up, right? Where we have 4 to the x. We're trying to see what power of 4 gives us 11, right? Is 11 a nice power of 4? No. Okay. But what can we at least estimate our x value to be? Okay. 2 is going to be more than 2 or less than 2. It's going to be less than 2 because what is 4 to the 2? It's 16. 11 is less than 16, so 2, we need a smaller power, right? If we said 4 to the 1, 4 to the 1 would be 4. So this x value here is going to be between 1 and 2. 4 to the 1 is 4, 4 to the 2 is 16, 11 is between those two, and so it's going to be between 1 and 2. Okay? But how do we find this exactly? Well, remember that I said that logarithms and exponentials are inverses of each other. All right? What logarithm could we use here? What logarithm of what base should we use here? Well, what's the base of our exponential? 4. Base of the exponential 4. So let's use log base 4. So we're going to take log base 4 of the left-hand side, and we'll take log base 4 of the right-hand side. Okay? Now, this is where you really need to make sure you know that definition of what a logarithm is or what it's asking for. When I take log base 4 of 4 to the x, well, we can kind of think of this two ways. Okay? One way is, if I want to simplify this, right, this logarithm is saying 4 to what power gives me 4 to the x? So 4 to what power gives me 4 to the x? What exponent of 4 gives me 4 to the x? Not 1. X, the exponent, right? This is the exponent. So this simplifies down to just x. Okay, this simplifies down to just x there. Equals, and then log base 4 of 11. Okay. Now, this is our precise answer right here. That's it. That's literally it. Okay. But let's go ahead and come up with a decimal here, just because, that's helpful too. And so we go to our graphing calculators. Okay. For those of you that have the math print, right, we'll go to log base. So log base right there, the math button, log base, right? And then we'll type in 4 and then 11. And there it is, about 1.73, we'll say. So about 1.73. Okay. For those of you that don't have the math print, remember you want to type in log of 11 divided by log of 4. Okay, just like that, right? For those of you that don't have the math print, you want to type it in like this, and then there's the same answer, right? So you take log of the big number divided by log of the base, and you get your answer that way too. Okay, so if you don't have that log base command in your calculator, okay. So there's that. Questions so far? Yeah. That will work as well if you want to graph it, yes. The only catch with that is sometimes you're going to have to be manipulating your window, some in order to find that point of intersection. But that will work too, yes. Yep. All right, so let's try another one here. All right, let's do 7 to the 9x equals 15. Okay. 7 to the 9x equals 15. All right. Watch this here, AJ. Okay. This is going to be on the test. All right. 7 to the 9x equals 15. What logarithm should we use here? Log base what?
3.
Not 3. 7. The 7 because 7 is the base of our exponential here. So use the base. Match your logarithm to the base. Okay? So we'll do log base 7 of 7 to the 9x equals log base 7 of 15. Okay? On the left here, 7 to what power gives me 7 to the 9x? What exponent of 7 gives me 7 to the 9x? 9x. The answer is 9x. This simplifies down to just 9x. Okay? At a very basic understanding, folks, when you take log base 7 of 7 to the something, the answer will be that something. Okay? Just the something, whatever that exponent is there. Okay? And then this equals log base 7 of 15. Okay? Have we solved for x yet? Have we solved for x here? No. What do we need to do to both sides? Divide both sides by 9. So the full answer without any rounding is log base 7 of 15 divided by 9. Okay? This is the precise answer, and this is the only way to write a precise answer. Okay? When we type it in our calculator and we get that decimal, we're now rounding things. So that's why I wanted to write the precise answer first, and now we'll go ahead and type in our calculator, use squiggly equal sign there. Okay? That is the official math symbol for like approximation, the squiggly equal sign. All right? So again, I'm going to use the log base, 7, 15, and then on the outside, divide the whole thing by 9. Okay? Just like this. Okay, we get about 0.155, we'll say, 0.155. Okay, just like so. Which if you want to check it, you can, right? So if I take 0.155, if I do 7 to the 9 times 0.155, right? So 7 to the 9 times 0.155, I'm checking it, I'm plugging it back in here for x up there. And we get about 15. Okay, you can see we don't get exactly 15 because I rounded my x value there when I plugged it in. Okay, if I were to take this exact value and put it in there, okay, then I would get exactly 15. Okay. All right. So there's that one. Questions on that? All right, we're going to look at one more here, and then we'll look at logarithmic equations. Okay, so like this is pretty much going to cover it. Okay, so one more here, and then we'll look at logarithmic equations. Okay. So here, okay, again, we have an exponential equation. What makes this equation exponential? Where is our variable? In the what? Base. Not in the base. E is actually a number. E is the number E. Where's our variable? It's in the what? It's in the power, the exponent. That makes us exponential. Okay, that makes us exponential here because we have our variable in the exponent. Okay, so again, you know, when it comes to solving equations and stuff like that, we want to recognize, okay, this is an exponential equation, so we're probably going to end up using a logarithm at some point. Should I go ahead and use a logarithm for my very first step here? No. Okay, but wait a minute, Mr. Widmeyer. We use a logarithm in our first step to solve this equation, and we use a logarithm in our first step to solve this equation. What's the difference here? What do I need to do then? Yeah, we got to add 7 first to both sides. We got to isolate, so this is important here, isolate the exponential. Okay? Right? When you isolate something, you get it by itself. Right? Prisoners that misbehave, they go to isolation. Put a cell by themselves. Apparently, it's pretty crazy. Or people, you know, it bothers people to do that. So. All right. All right. Can we use the logarithm now? No. What should we do next for our next step here? Divide by 4, right? We still haven't isolated the exponential. E to the negative 0.3x, that's our exponential. So we got to get rid of that 4. So we'll divide both sides by 4 there. E to the negative 0.3x equals 5. Okay? E to the negative 0.3x equals 5. Now can we use the logarithm? Yes. To eliminate E, what special logarithm do we use? ln, natural log, exactly right. So we're going to use natural log of both sides there. What's the left side going to simplify to b? Remember, the natural log and the e will just cancel. So we'll just get negative 0.3x equals, and then the natural log of 5. Okay? And then how can I get the x by itself here? What should I do to both sides now? Divide both sides by negative 0.3. Exactly right. So x equals natural log of 5 divided by negative 0.3. Okay, bless you. And when I type that in my calculator, like a so, we get about negative 5.365, we'll say. So actually I'll do it this way. Well, no, I'll do it this way. So the exact answer is natural log of 5 divided by negative 0.3. But approximately it is negative 5.365. Okay. Now, as Braylon asked earlier, Mr. Witt, can I just grab the left-hand side, grab the right-hand side, find the point of intersection to find the solution here? The answer is yes. You can just do that, yes. But again, you'll have to be comfortable with manipulating your window. You have to make sure you type it in accurately and stuff like that. But yes. Okay. Questions on that? That's exponential equations. Okay. So let's take a look then at solving logarithmic equations. All right. So if we have an exponential equation, we use logarithms. If we have a logarithmic equation, we're going to use exponentials to cancel them out. Okay? It's just, again, they're opposites, right? They're inverses of each other. So to solve a logarithmic equation, we'll just use exponentials. Okay, and we'll do about 3 here as well. Can I remove this page here? Is everyone done with it? Hold on to that there. Let me get my notes for this. Here we go. Okay, so let's do some basic ones here to start out. Okay. Yeah, okay. Okay, basic ones here to start out. Now, some of you already might know the answer to this. What is this? What is x going to be here? Yeah, so what value is x going to be in this particular case? Log base 2 of 8 is equal to what? 3. It's 3. The answer is going to be 3. Yeah, the answer is going to be 3 here. All right. We know how to do this because we can rewrite this thing using, exponential form. But let me show you an alternative way to think about this, right? So again, in an equation setting, right, the issue here is that I want to solve for x, but I'm not really sure what this is. So we could just type this into our calculator at this point, right? We can type in log base 2 of 8. That's one way to do it, okay? We can also, though, use the logarithm's base here of 2. We can use that to eliminate the logarithm. What do I mean? So back when we did the logarithmic equations, right, when I had here, I'll use this one in this case. We had 7 to the 9x. I wanted to get the 9x out of the exponent there, so I used log base 7 and log base 7 on both sides, right? I used the logarithm to eliminate the exponential. Here, I have a logarithm. To eliminate it, I will do 2 to the left-hand side and 2 to the right-hand side. So I will make the left-hand side a power of 2 and the right-hand side a power of 2. Question, sorry?
Why do you do that?
Because exactly, we match the base of the logarithm to the base of our exponential we're going to use. Now, 2 to the log base 2 of 8 will simplify to be just 8. We'll cancel and simplify to be just 8. And then 2 to the x, we'll write that as 2 to the x. Okay. And so maybe now it's easier to see what does x have to be in order for 2 to the x to be 8. Well, 2 to the 4, that'd be 2 times 2 times 2 times 2. That's going to be 16.
2 times 2 times 2.
So 2 times 2 times 2, 3. Exactly. So x must be 3 here, right? Just like that. Okay. We can do something similar with a problem like this. Try another one here. Log base 4 of x equals 3. Okay. Again, maybe you look at this and you're like, ooh, I'm not really sure what this is equal to. What base can we use here to cancel out log base 4? What's our base that we're going to use here? 4. Yeah, so we'll just do 4 to the left-hand side, 4 to the right-hand side. The 4 to the log base 4 will cancel. You're left with just x here. And then our answer over here will be 4 to the third. 4 to the third is 64. And there's our answer. Okay? So we're just using an exponential.
Why just 64?
4 times 4 is
8.
16 times another 4, 64. Yep, I just did it. Yeah, I just did the math. That's all. Okay? So now let's try something a little more advanced, a little more tricky, I guess we'll say. Log base 4 of 5x minus 1 equals 3. Okay? What base will cancel out log base 4? 4. So we're going to use 4 to the left-hand side, 4 to the right-hand side. When I say 4 to the left-hand side, I mean the entire left-hand side goes in the exponent of 4. And the entire right-hand side goes in the exponent of 4 as well. Okay? The 4 to the log base 4 will cancel, and we're left with just 5x minus 1 is equal to, and then 4 to the third, well, we know that's going to be 64, right? So I'll just go ahead and write that. Okay? And then at this point, right, it's like algebra 1. Maybe even, pre-algebra kind of stuff, right? Add 1 to both sides. Divide both sides by 5. 13. Okay? So the algebra 2 part of this, your responsibility, right? How you're expanding your knowledge here and growing as an algebra or math student, right? We are using our understanding of logarithms to eliminate the logarithms so we can then just solve this two-step equation now.
So is it 64 or 65?
Well, so it was 4 to the third, which is 64. Then we add the 1 to both sides to make it 65. Yep. Okay? I'm going to do 2 more here. I think I should have enough time for 2 more. Okay? Okay, change it up a little bit here, just to make it a little more interesting. Okay. Log base 5 of 4x minus 7 equals log base 5 of x plus 5. So now we have logarithms on both sides. Okay. Logarithms on both sides. What base should we use here, though, to cancel things out? 5. Yeah, they're both the same base, so we'll use 5. Okay. You're not going to run across an equation. You will not run across an equation, okay, where the base of the logarithms will be different, right? So you'll never see a situation in our class where you have like log base 5 and like log base 7 over here or something like that. Not going to happen. All right, so the 5 to the log base 5 cancels. What's left over here? Yeah, just 4x minus 7. 5 to the log base 5 cancels out here. What's left over here? X plus 5. And then you guys know how to solve from here, right? Subtract x from both sides. We'll get 3x minus 7 equals 5. Add 7 to both sides. We'll get 3x equals 12. Divide both sides by 3. X is 4. Okay. Again, the only algebra 2 step here, the only algebra 2 step is right here, where we eliminate the logarithm. Okay. Question? Well, actually, if you can hang on for just like 1 or 2 more minutes, I just want to show you this next thing. I don't want you to miss it, that's all. I just want you to miss it. I mean, not mind-blowing, but it'll be helpful if you're here to see it, that's all. Okay. So, because this one is a little bit different, CJ. But thank you for your patience. All right. Okay, so I'm kind of like... All right. Now, what's unique about this equation as compared to the earlier ones that we've done? What's unique here? What's different?
No base.
Okay, no base. What do we understand the base to be if there's no base written? 10. Okay, that's good. What else is different about this one, though? 2 logs same side. Yes, 2 logarithms on the same side. Since we have 2 logarithms on the same side, what we need to do here, and this is the important kind of like step we want to take into account. We want to combine multiple logs into a single log, okay, using your properties. This is part of the reason why we learned those log properties. This is why they were part of the quiz yesterday, okay, that the stuff where you're supposed to take multiple logarithms, condense them, put them together to a single logarithm. It's because you need it for the equations. We really need it for the equations here, okay? So, when we have addition between 2 logarithms, what can we condense that to be? Multiplication. So it'll be log of 2x times x minus 5 equals 2. Okay? We took 2 logarithms that are being added. We condensed it to a single logarithm, but then multiply what's inside together. Okay? If you don't understand those properties, you're also going to be in trouble for these equations. Okay? So you're doubly hurt if you don't understand those properties yet. The good news is you still have time to figure those properties out before our test on Tuesday. So please take the time to do that. Come in for set, stay after school, before school. Come ask me questions in class, whatever. All right, I'm going to go ahead and distribute the 2x times the x and the minus 5. So we'll have 2x squared minus 10x in there, like this. But now how should we solve? How can I eliminate that logarithm that's there? Use the base of 10. So we'll do 10 to the left-hand side, 10 to the right-hand side. Do not use a base to cancel things out if you have more than one logarithm. You must combine those 2 logarithms together to a single, then cancel it out. All right, 10 to the log cancels. We've now got 2x squared minus 10x equals, what's 10 squared simplify to be? 100. Ooh, this is a quadratic equation. In order to solve a quadratic equation, what do we have to do? Make sure it's equal to 0. So we'll subtract 100 from both sides. And then we need to do what? Factor. Or if you really want to, use quadratic formula too. Now, I go to factor this thing. I see a GCF. What's our GCF we can pull out here?
2.
2. Yeah, 2. That's okay. Okay, now, since my lead coefficient here is 1, I mean, yes, there's a 2 in front there, but in the quadratic here, my lead coefficient is 1. I'm looking for two numbers that multiply to negative 50 and add to negative 5. Negative 10, positive 5. Okay? And so then set each factor equal to 0. Woo. And so you get x equals 10. There's one of our solutions, and x equals negative 5. Okay? You need to check your answers, okay, for extraneous answers. Okay, and negative 5, when you plug it back in, it actually does not work. So only 10 works there. Okay? And that's all I have to say about that. So, I will be posting homework to Google Classroom, so please check that. Okay? I will be posting homework to Google Classroom, so please check that for your homework assignment. Okay?